Hello guys, welcome to another video of organic chemistry. Today I'm going to show you Fisher's esterification, and I'm gonna start by drawing the carboxylic acid. I wrote the code for this reaction, as you can see, is on top of the writing, and I wrote ec for acidic, and I'm writing a reagent number 1. It has a positive charge. So you can see I put it in the code, and it's going to have a nucleophilic attack. It goes from the hydrogen to the oxygen. As a result, I wrote it has a pi bond and oxygen positive charge. It's there. Next step, it's reagent number 1 becomes stable, is no longer an acid, it's not protonated, and it's an alcohol, methanol. Methanol is reacting with the carboxylic acid as a electron withdrawing group. Here we see it, oxygen. Sorry, I should have wrote the oxygen attached to the hydrogen. It's being fixed with the metal, and there it goes, electron withdrawing group. There is a shift of electrons going to the most electronegative atom. Next, I have the diol as I put it in the code. Just remember, the code is going to serve as a cheat note on a test. That's why I have it there. And now I wrote the methyl group has a positive charge, which means that, the oxygen has a positive charge. Now it's gonna have a hydrogen and the methyl, and we're on step where the reagent 1, I'm marking it off, working on that step, and acts as a nucleophile. It's a 1-1 reaction. It's gonna give us a diol and an ester. And there it goes, acting once again as a nucleophile. Sorry, and it's going directly to the hydrogen, moving to the oxygen with a positive charge. Result is a diol. Next is the alcohol is acting as a nucleophile again. It loves the hydrogen. So I have this time as reagent 1, the protonated alcohol. The protonated alcohol is going to have a shift. Positive charge there, thank you. And now the sigma bond becomes protonated in the oxygen. There it goes. We're gonna have a different reagent. And I am about to draw it in the next step. The sigma bond that we said, and there is a sigma bond. 2 hydrogens for the sigma bond. Ester. It's no longer an ester because it doesn't have the ketone anymore. It will be an ether, right? Now becomes an ether, and the next reaction is a not between the alcohol and the hydride. There it is, not between itself. It's not going to react with reagent 1. Sorry, it should have been from the all to the hydride. Perfect. As you can see closer, I am gonna draw the next step to my left, and there is gonna be a loss of a leaving group. The alcohol is going to leave, and I'm gonna be left with a pi bond, oxygen having a positive charge. Now it is an ether, an ester, my bad, because the ketone. And the final step, we have reagent methanol acting as the active reagent. One attacking the nucleophile is not an electro-withdrawing group. It is a nucleophile. If it was an electron-withdrawing group, it will be attacking the most steric carbon next to the oxygen and double bond of the oxygen as well. Final step, we're checking that we did have the final result, and we did. Thank you for listening. Share with someone if you think it's helpful.